Hello everybody, this video is about all the common terms used in the introduction of an electric circuit. Electric circuit. Okay, so in order to understand what is an electric circuit, we need to understand what is an electric current. Okay, for that, consider a short length of copper wire. This is a short length of copper wire. Now consider an imaginary plane which will be placed perpendicular to this copper wire. That is like this. Okay. We know that all the things are made up of atoms, and similarly atoms will be having of protons, neutrons and electrons. And here the electrons will be moving from this end to this end. That is, it will be continuously crossing over the plane. At any instant, the number of electrons crossing the plane from right to left will be equal to the number of electrons crossing from left to right. Okay. At any instant, the number of electrons crossing from right to left will be equal to the number of electrons crossing from left to right. Therefore, what will be the net number of electrons crossing? Net number of electrons crossing will be 0. Because both of them are equal, it will be cancelling out, so it will be 0. So, such random movement of free electrons cannot constitute an electric current. Such random movement cannot constitute electric current. Cannot constitute electric current. Okay. Now consider the same figure once again. That is copper wire of short length, an imaginary plane which will be placed perpendicular to it. Now we are connecting both the free ends of the copper wire to a battery, to a terminal, whatever is. Okay. Now, consider the electrons in this copper wire crossing across a plane will experience a constant electric force. The charged particles will experience a constant electric force. Because of this force, the electrons will tend to move towards a positive terminal. Because of this force, electrons will tend to move towards a positive terminal. In addition to having random motion, these electrons will continue to move towards the positive terminal. So what will be the result of this? The number of electrons crossing the imaginary plane in one direction. This direction will be more than this direction. The number of electrons crossing in this direction will be more than this electrons crossing in this direction. So the net flow of electrons in the conducting material causes an electric current. This net flow in one direction across the conducting material will cause an electric current. Okay. The direction of electrons will be flowing in this way, like this. So the direction of the conventional current will be opposite to that, because electrons are negatively charged, current is positively charged, and that is what is known as a current. And we will be measuring the current in terms of ampere, which is A. So what is a current? Current is a net flow of 1 coulomb of charge across a plane in a conductor in 1 second. Therefore, I is equal to Q by T. 1 coulomb of charge in 1 second. That is known as an electric current. Now another term associated with electric circuit is a potential. What is a potential? Consider any point P. So the potential at any point P is the amount of work done in order to bring a unit positive charge from infinity to point P. So the potential consider point P. The potential at point P is the amount of work done in order to bring a unit positive charge from infinity to point P. The potential will be represented in volt, that is V. Okay. Now what is an electromotive force or EMF? EMF or electromotive force. Electromotive force or EMF is a pressure or voltage. Is a pressure or voltage which causes an electric current to flow in a circuit. So what is it? EMF is a pressure or voltage which causes an electric current to flow in a circuit. The unit of EMF is also volt, that is V, because it is pressure or voltage. Now resistance. What will be the resistance? The property of a substance, that is, if current is flowing through this pencil, imagine if the current is flowing through this pencil, there will be some resistance offered to the current flow by this pencil. That resistance is known as, that resistance which opposes the property of opposing the current flow through the conductor is known as resistance. Okay, the unit of resistance is ohm. Okay, now resistivity. The resistance of a conductor depends upon the following factors. The first one is the material. Which material opposes that? If it is a pencil, then this. If it is this water bottle, then it is plastic. If it is a metallic conductor, then it is copper, whatever it is. That it depends upon the material. For example, silver is always a better conductor than copper. Silver conductor. And resistance of a conductor depends upon its materials. First one, silver is better than a copper. Better conductor than copper. Now, the second property in which resistance depends upon is about the length. The resistance of a conductor is directly proportional to length of the conductor. Okay. Third one is the cross-sectional area. This resistance is always inversely proportional to the cross-sectional area. Now the fourth one is temperature. The resistance always increase with increase in temperature. Okay. But carbon, silicon and other insulators decrease with increase in temp. So what is a resistivity? So R is equal to, by putting all these two things together, we'll get that we know that R is directly proportional to L. R is inversely proportional to 1 by A. So we know that R is directly proportional to L by A. When we have to, for putting an equation, that is putting equal sign, we need to put a constant of proportionality. That is known as rho, L by A. Okay, rho is the specific resistance or constant of specific resistance of the material or the resistivity. This rho is called as resistivity. Therefore, what is rho? Rho is equal to what? R into A by L. Okay. If area of cross section is 1 meter square, and the length is 1 meter, then rho is equal to R. Everything else will be 1. So it will be equal to rho is equal to R. Now the temperature coefficient of resistance. For that, consider conductor. Okay. The conductor will be having a resistance R0 at 0 degrees Celsius. And the conductor will be having a resistance RT at T degrees Celsius. Therefore, what will be the increase in temperature? Increase in temp is equal to delta R, which will be is equal to RT minus R0. Okay, the increase in temperature will be denoted by delta R, which will be equal to RT minus R0. Sorry. Okay, RT minus R0. Now the change in resistance is directly proportional to the initial resistance. That is what is the change in resistance? This delta R. Delta R will be directly proportional to the initial temperature, that is R0. And it also be proportional to the rise in temperature. What is the rise in temperature? T degree. That is, it will be rising from 0 to T. Therefore, T minus 0 is equal to T. That is R0 into T. Okay, directly proportional to. We will be removing the proportionality by a constant known as alpha 0. Okay, alpha 0 R0 T. So what is this alpha 0 known? Alpha 0 is known as the temperature coefficient of resistance of the conductor at 0 degrees Celsius. Temperature coefficient of resistance at 0 degrees Celsius. Therefore, delta R is equal to what? Alpha 0 R0 into T. Okay. So from this we have to find out what is alpha 0. Alpha 0 is equal to what? Delta R by R0 into T. So what is delta R? Delta R is RT minus R0. Therefore, RT minus R0 by R0 into T is equal to alpha 0. Right. Now, RT minus R0 is equal to what? Alpha 0 into R0 T. Right. Now, what is RT? RT is equal to R0 plus alpha 0 into R0 T. From this, take out R0, which is a common factor. Therefore, 1 plus alpha 0 T. This is RT. That is, this is the formula to find RT, find out the resistance of a material at T degrees Celsius when the resistance at 0 degrees Celsius is known. That is, when R0 is given in a problem, if we want to find out RT, then we have to apply this formula. Okay. This is known as the temperature coefficient of resistance. Now, what is the effect of temperature? Effect of temperature on alpha. Okay. Now here, let alpha 0 and alpha t be the values of temperatures of temperature coefficient of resistance, let alpha 0 and alpha t be the temperature coefficient of resistance at what? 0 degrees Celsius and T degrees Celsius. Okay. Therefore, let alpha 0 and alpha t, what are alpha 0 and alpha t? They are the temperature coefficient of resistance. Alpha 0 at resistance resistance 0 degrees Celsius and temperature 0 degrees Celsius, and alpha t, temperature T degrees Celsius. Okay. Let R0, the resistance at what? 0 degrees Celsius, and RT at T degrees Celsius. But we know RT is equal to R0 into 1 plus alpha 0 T. The equation we found out just before. RT is equal to alpha R0 into 1 plus alpha 0 T. Okay. Now, imagine if the conductor is cooled from what? From T degrees Celsius to 0 degrees Celsius. Okay, then what will happen? Then we have to find out R0. So what is R0? R0 is equal to RT into 1 plus alpha T into minus T. The difference is minus, like 0 to T is minus. That is why minus T came. Now, what is this equation? R0 is equal to RT RT minus RT 1 plus, no, this sign will come minus alpha T. This is the equation. Okay, now we have to bring this to this side, that is RT, that is if R0 is equal to RT minus RT alpha T. Now we have to bring this to this side, that is RT alpha T is equal to RT minus R0. So what is alpha T? Alpha T is equal to RT minus R0 by RT into T. Okay. Now we have to substitute the value of RT here. What is RT? RT is equal to R0 into 1 plus alpha 0 T minus R0. Now here also we have to substitute the value of RT, which is R0 into 1 plus alpha 0 T into T. Okay. Now we have to simplify the equation. That is, now take R0 inside the equation, inside the bracket. So R0 plus R0 alpha 0 T minus R0 by, here also we have to take R0 inside. So what is it? R0 plus R0 alpha 0 T into T. Now here R0 is a common factor. Take the common factor outside. That is R0 into 1 plus alpha 0 T minus 1 by denominator R0 into 1 plus alpha 0 T into T. Okay. Now R0 will get cancelled. What is the remaining? 1 minus 1 is 0. Therefore alpha 0 T by 1 plus alpha 0 T into T. Both T will get cancelled. Therefore alpha 0 by 1 plus alpha 0 T. This is alpha T. That is the effect of temperature on alpha. Please check the equation once again. If there is any doubt, you can message me. And that's all regarding the the basic terms of an electric circuit. My next video will include all the main parts like Thevenin theorem, Kirchhoff's law, Norton's theorem and all. Thank you.